Japan just announced today that they plan to release over 1 million tons of radioactive water into the sea this year.
So, key thing there is, he just said 1 million tons of water. It could have been 1 billion tons or 1 trillion tons. What matters here is not how much water is being released, but the concentration of radioactive material in that water and how much radioactive material total that is being released. The concentration of radioactive material that they're going to be releasing into the environment is 1,500 becquerels per liter. And that is actually pretty low, which I'll explain later.
The water they're referring to is from the FUKUSHIMA nuclear power plant disaster in 2011. And for 12 years now, workers have had to pump water through the ruins to prevent the debris from overheating and causing further damage. They then collected, filtered, and stored all of that contaminated water into 1,000 steel tanks crammed onto the Fukushima campus.
Key thing there is he said filtered. And that's really important. What they actually do here is they're pulling groundwater out of the fuel debris, and then they take that contaminated water that has all sorts of different contaminants in it, like cesium and strontium. They pass it through what's called the advanced liquid processing system. That removes a vast majority of those radioactive materials, but it doesn't remove your tritium. Tritium is an isotope of hydrogen, so chemically it behaves exactly the same way. When hydrogen is in water, it is that H in the H2O. It's really hard to remove that H out of the H2O because it's going to chemically behave the same way. You can't remove water out of water,
which is now running out of space. The IAEA said that the release is safe, and the Fukushima operator
the IAEA should be a good trusted source. They are the experts recognized internationally.
Later said, and I quote, "After treatment, levels of most radioactive particles meet national standards."
So, when he says most, what does not meet the national standard is those levels for tritium, because they can't remove the tritium from the water. But what they are going to do is the water that they're going to be releasing into the environment is going to still be below the regulatory requirements. What they do is they mix it with seawater first before releasing it. That's how they get it down to that 1,500 becquerels per liter. These results aren't just coming from TEPCO or the Japanese government or even just the IAEA. It's coming from a whole host of countries. This long list of international laboratories is forming a group called the Interlaboratory Comparison. Countries that make up these laboratories are Korea, France, Switzerland, and the US, which really leaves no room for hiding anything.
However, neighboring countries and local fishermen have voiced their concerns. So the question is, do you think this is safe, or are we going to have a whole load more of these appearing this year?
So one of the big reasons why this is such an issue is because of that communication with the public. I don't blame fishermen for being concerned about this contaminated water being released into the environment. It is safe, but it really does put a bad image on those fishermen in Japan and from neighboring countries. So really, this isn't a major pollution concern, but more of a public perception concern. And unfortunately, the media and videos like this really escalate that bad perception that people have of this release that's happening. This release should happen. It is safe, and this is the way that you release tritium into the environment. You either release it into the water or you evaporate it into the air. Tritium, as I've mentioned before in some of my videos, has a very low health hazard. It's actually released as a normal everyday practice from facilities around the world without having any effect on the environment. That's because tritium does not concentrate in the ecosystem like things like heavy metals and mercury. If it was easy to concentrate, we'd know how to remove it. The results of releasing this low level of radioactive material into the ocean is very minimal when it comes to the animal life. The amount of dose that is expected to be received by humans from this release is less than 1/100th of one dental x-ray. Now, to put things into perspective, if you wanted to receive the same dose that you would from the naturally occurring radium in one Brazil nut, you would have to drink 3.5 liters of that Fukushima water to get the same dose of radiation. So again, anytime you see the news putting out information like this, remember to put things into perspective.